Hi everyone. In last video I explained type of multiplexing. First one is FDM, second one is WDM, third one is TDM. I already explained FDM in last video. In this video I am going to explain WDM and TDM. WDM is wavelength division multiplexing. It takes the input as analog signal. Next one is time division multiplexing. It takes input as digital signal. Now I am going to explain wavelength division multiplexing, nothing but WDM. WDM is an analog multiplexing technique that combines the analog signal. Nothing but for wavelength division multiplexing we use analog signals as a input. Okay, you can see in this figure WDM, it use max, Dmax. These are the input line, these are the output line. To connect and communicate we use link. Here that link is high data rate capacity of fiber optical cable. We use to connect and communicate this max and Dmax. We use fiber optical cable. Why we are using fiber optical cable means the data rate of fiber optical cable higher than the data rate of metallic cable, means it has a higher data rate than the metallic cable data rate. So we are using fiber optical cable to connect and communicate between the max and Dmax. And use of fiber optical cables for single line means the wastage of the available bandwidth. Means here you can see that 1, 2, 3 input signals are there. Okay, suppose we used only one input line, means here the bandwidth is more here in the fiber optical cable. So if we use only one line means there will be a wastage of available bandwidth. So we should use more input signals in the WDM, nothing but wavelength division multiplexing. Now shall we discuss how max and Dmax will work. Max means multiplexer, Dmax means demultiplexer. You can see that here how it works. Multiplexer combines several narrow band of light into wider band of light. Means here the analog signals we used as bandwidth of light. The input here is bandwidth of light. This is also an analog signal. Okay, so multiplexer will combine several narrow bandwidth of light into wider bandwidth of light. Means the several narrow bandwidth going to combine to form a wider bandwidth of light. Next one is demultiplexer. What this demultiplexer will do means the demultiplexer is opposite to multiplexer. Here demultiplexer divide a wider band of light into several narrow bands of light. Means it is going to combine here it will going to divide, means the multiplexer is deadly opposite to multiplexer. And in WDM, multiplexer and multiplexer devices use prisms. You can see that here also prism is there, here also prism is there. This is prism, this is also prism. Prism used for combining and splitting, nothing but dividing of light source. Why we are using this prism means for combining and splitting of the light source. A prism bends a beam of light based on angle of incidence and frequency. Okay. Next, what is the application of wavelength division multiplexing? It has two applications. One is SONET network. What is meant by SONET network? Multiple optical fibers lines can be multiplexed and demultiplexed. This is SONET network. Next one is then WDM. What is meant by WDM? Means here multiplexing a very large number of channels by spacing channel very close to one another, means it going to attach the channel very close. That is the use of this WDM. The last type in the multiplexing is TDM, nothing but time division multiplexing. What is mean by TDM? We are going to discuss here. TDM is a digital multiplexing technique that combines the digital signals. Means TDM takes the input as digital signal. Here TDM combines several low rate channel into one high rate link. Means these are the 1, 2, 3, 4 are the low rate channel. After multiplexing, we are going to get this high rate link. Okay. Next, what is the difference between FDM and TDM? FDM means frequency division multiplexing. It is a portion of bandwidth is shared. In FDM, portion of the bandwidth is shared. In TDM, a portion of the time is shared. That is the difference between FDM and TDM. Now we will discuss how this TDM work. As shown in the figure, link is divided by time, means this is divided by times 1, 2, 3, 4 like this. Okay. Portion of a signal 1, 2, 3 and 4 occupies the link sequentially, means these are the signals, this occupies sequentially 1, 2, 3, 4, next 1, 2, 3, 4 like this. In detail we'll discuss later. Okay, for understanding keep this concept here. Means what is sequence? Means first year, second year, third year, fourth year, like this we are going to keep the data in the sequential order. Okay. TDM is considered as digital multiplexing technique. Okay. I told that here TDM will take input as digital signals, but sometimes the source can produce analog signal. Means sometimes the source means this side, these signals may be a analog signal. So here we have to convert this analog signals to digital data, then you have to multiplex by using TDM. Okay, here in TDM there are two types of. First one is synchronous, second one is statistical. Okay, first we will discuss what is meant by synchronous. Next we will discuss statistical. Okay, under synchronous TDM there will be a 5 concept. First one is time slots and frame. Second one is intervalling. Third one is empty cells. Fourth one is data rate management. Fifth one is frame synchronization. We will going to discuss one by one under synchronization TDM. Okay, first in synchronization we will discuss time slots and framing. What is meant by time slots and framing? Observe here, each input connection has an allotment in the output connection if it is not sending data. Means observe here, this is the diagram of time slotting and framing. Here this one are 3 input connection. Here you can observe this is an output connection. Here you can observe that A1, A2, A3, B1, B2, B3, C1, C2, C3 are the data flow, means information. A1 is one information, A2 is then one information, A3 are one information. Okay, suppose if there is no information in second line also, the output connection will create the slot. Okay, this is the explanation of this first statement. Second statement is data flow of input connection is divided into units. Means data flow is nothing but here A1, A2, A3, B1, B2, B3, C1, C2, C3 are the data flow. Here it is divided into unit. Unit nothing but we will call it as slot. Here this is A1 is one slot, B1 is one slot, C1 is one slot. Means it will take as A1 here, second line B1 here, third line C1 here, like that. This is called as frame. This is called as one frame. Means each data flow from each of the line. Suppose if there are 5 line input lines, means it will consider as like this: A1, B1, C1, D1, E1. Means it will create 5 slots. Then the frame first is formed. Means the frame 1 contains 5 slots. But in this diagram there are 3 data flow. Then it is having only 3 slots in the frame 1. Frame 2 also there are 3. Frame 3 also there are 3 slots. Okay, I told her this is data rate. This data rate is nothing but data flow of input connection is divided into unit. Unit nothing but unit is equal to 1 bit, 1 character, 1 block of data. Nothing but here A1, B1, C1 are the units. Each input unit occupies 1 time slot. Here this A1 is 1 unit, this occupies the one input time slot. This is slot means this one unit will occupy one slot in the frame. Okay. Next, each input unit becomes one output unit, occupies one output slot. Nothing but I explain now. Here this is one unit means it is going to occupy one output slot. Okay. Next, duration of output time slot in n time shorter than the duration of input time slot. You can observe that the frame containing T and this A1 is T by 3 means this is frame we will call it as 3, but in this frame there are 3 slots A1, B1, C1. So the T is divided by 3. Okay. This means that input time slot is this and output time slot is T by n. N is nothing but numbers. How many units we are going to occupy in this frame? 1, 2, 3. There are 3 slots. Okay. Here n nothing but number of connection. 1, 2, 3. There are 3 connections. Okay. For better understand, consider this figure. Here you can see that there are 4 connections. 1, 2, 3, 4. There are 4 connections. Then here the frame will be divided into 4 slots. Consider here 1, 2, 3, 4. This is one slot. Here to here another slot. Here to here one frame. In one frame there are 4 slots. 1, 2, 3, 4. Like that only. Here to here another frame. Here also there will be a 4 slot. 1, 2, 3, 4. Next, here to here another frame. It contains 4 slots. 1, 2, 3, 4. Like this only. If there are 4 connection means then each frame will have 4 slots. Okay. Then how this here 1, 0, 1, 0, 1, 0, 0. These are the unit, or we are going to call it as bit. How these units will occupy these slots means you can observe that you observe that this is one frame containing 4 slots. How the units will occupy these slots in frame means first the first line will consider. In first line what is the unit is there? 1 is there. 1 will be occupied first slot in first frame. Second 0. In second line the unit is 0. Here in first frame second slot will be occupied by 0. Third line there is 1 unit. Here in first frame the third one will be occupied by third slot will be occupied by 1 unit. Next one is fourth one is we are having 0 unit. Then 0 will be occupied at the last slot of frame. Okay. Next we will consider this frame. Here next in first line we are having the unit 1. The 1 is occupied. In second we have 0, 0 is occupied. Next here also 0 is there, 0 is occupied. Next 0 is there, 0 is occupied. Like this the unit will be occupied the slots in the frames. Okay, this is the time slotting and framing concept. Okay, next concept in synchronization is interleaving. What is meant by interleaving? Before going to that, we will know some concept to understanding interleaving. The TDM have two fast rotating switches. Here for explaining the interleaving, we are going to consider, in this concept we are going to consider two fast rotating switches. First switch on the multiplexing side, second switch on the demultiplexing side. In this figure you can observe that this is one fast rotating switch, this is another fast rotating switch. This is multiplexing side, another one is at demultiplexing side. Okay, but here you can see that two switches are synchronized, rotate at the same speed. Means these two switches will be rotating at a time at the same speed but in opposite direction. Means you can see that it will rotate in this direction, it will rotate in this direction. Means the two switches are synchronized, rotate at same speed. Means that these two switches will be rotating at same time with same speed but in opposite direction. Okay, next we will see that how multiplexing side is work, how demultiplexing side is work. In multiplexing side, as a switch open in the front of the connection, this is front end. When switches open in the front of the connection has the opportunity to send an unit onto path. Means whenever the front end is open, the unit will send to path. This is path. From here to here the units will be sent. In demultiplexing side, as the switch open in the front of the connection, here if the switch is open means has the opportunity to receive a unit from the path. From here the unit is passed to here. Okay, means what they are telling means in multiplexing side, if the switch is opened, then the sender will send the units to the path. Means unit to the link. What this demultiplexing side will do means, when the switch is open, the units from the path or link will send to receiver. Okay, this is the working of this. I told that interleaving. What is interleaving means? When multiplexing side is open, this switch means the sender will send the units to the path, that is interleaving. Okay, next concept is empty slot. What is meant by empty slot? Here we can see problem: synchronization TDM is not efficient. Why the synchronous TDM is not efficient? If the source does not have data to send, the corresponding slot in the output frame is empty. You observe here that they are telling that if a source does not have data to send, corresponding slot in output frame is empty. You can observe that this is one line, this is another line, means here there are 4 lines. In first line there is a data to send, in second line there is no data, in third there is the gap between the data, in fourth line we have the data. They told that if a source does not have the data to send, corresponding slot in the output frame is empty. So here you can observe that this is one frame, this is second frame, this is third frame. In first frame there is one slot is empty, in second frame 2 slots is empty, in third frame 1 slot is empty. Why empty means this data will be occupied here. Here in second line there is no data to send, so here it is empty. Okay, next there is the data to send, here data is occupied, here data is there, data is occupied. Here there is one slot is left empty because here there is no data to send. Okay, next in second frame there are 2 slots are empty because here you can observe that here data is there, here there is no data, here there is no data, so there is 2 slots are empty in frame. In third frame there is 1 slot is empty because here data is there. Okay, it is occupied 1 slot. In second line there is no data to send, so it is empty. Third there is a data, it is occupied. Fourth there is data, it is occupied. So to overcome this slot empty, there is a solution, is that have to use statistical TDM. Why we should use statistical TDM means it can improve the efficiency by removing empty slot. Means in statistical TDM you are going to remove this empty slots. Okay, next fourth concept is in this synchronization is data rate management. Problem in TDM is that how to handle difference in the data rate, input data rate. Suppose that is means if data rates are not the same. Here if data rates are not same means suppose there are 3 input lines A, B, C. These are 3 input lines. Data rates are not same. Suppose it is having 40, this is having also 40, this is having 30. This is the meaning of this data rates are not same. You can observe that B and C having 40 but A is 30. In this case, how we can manage data rate? Here there is 3 strategies to maintain this data rate. It can be maintained by multi-level multiplexing, multi-slot allocation and pulse stopping. Okay, we'll going to discuss one by one. Okay, first one is multi-level multiplexing. Here when data rate of an input line is is multiple of others. You can see that this is one input line, this is one input line, this is one input line, this is one input line. But this first one is the combination of other two input lines. That one only they are telling that when data rates of an input line is the multiple of others, means this will be multiple of other two lines. That one only they are telling. Why we are using this multiple of others means, here you can see that in second there is 40 kbps, in third also there are 40 kbps, in fourth line also 40 kbps of data rate is there. But in first and second for 2020 is there. So you are going to combine these two and make one line, that is 40 kbps. This is multi-level multiplexing. Next one is multiple slot allocation. What is mean by multiple slot allocation means, sometimes it is more efficient to allocate more than one slot in a frame to single input line. What does mean by this means, here you can see that there are 4 input lines, 1 2 3 4. Okay, there are 4 input lines, but you can observe that in this frame there are 5 slots, 1 2 3 4 5. So here 5 slots is there, here 4 input lines are there. So there is one extra slot. To fill this one extra slot, this 5 kbps will be divided into 2 separate lines. Means here you can see that this symbol representing demultiplexing of 50, means we are going to divide this 50 into 2 parts. So we can fill this 5 slots also. This 25 will be filled here, will be filled here. This is the concept of this multiple slot allocation. Third one is pulse stuffing. Nothing but sometimes the bit rate of sources are not same of each other. You can observe that this is 50, this is 50, this is 46. Okay, here we cannot multiplex also, demultiplex also. Nothing but we are not going to use this multi-level multiplexing also, multiple slot allocation also. In that time we are going to use pulse stuffing. Nothing but we are going to add 4 bit to this 46 kbps. Means we are going to use this pulse stuffing to increase from 46 to 50. Okay, this is pulse stuffing. Then we are going to multiplex this 3, then we will get the 150 kbps. Next concept is frame synchronization. Here the problem is synchronization between the multiplexer and demultiplexer is a major issue. Synchronization means matching between multiplexer and demultiplexer is a major issue. If the multiplexer and demultiplexer are not synchronized, means if the multiplexer and demultiplexer are not matched, then a bit belongs to one channel may be received by the wrong channel at the output. This is the problem if the multiplexer and demultiplexer is not synchronized or matched. To overcome from the problem of synchronization between the multiplexer and demultiplexer, there is a solution. Usually one or more synchronization bits are added to beginning of each frame called as forming bits. You can observe that 1 0 1, these are the bits. Okay, these are synchronized pattern, that is these bits are adding at the front, okay, of the each frame. We can observe that 1 is added here, 0 is added here, 1 is added here. This is called as forming bits. These forming bits allow multiplexer and demultiplexer to synchronize. Okay, this is the last concept in synchronization. Next one is statistical TDM. I told that in the explanation of synchronization, when we are going to use this statistical TDM means, here the statistical TDM can improve the efficiency by removing empty slots from the frame. Suppose in the frame there is empty slots, means we can remove by using this statistical TDM. Okay, we will discuss. Okay, statistical TDM. The problem synchronization TDM is not efficient. Why it is not efficient? I explained that if there is no data rate to send, then also the frame having the empty slots. To overcome that, we are using statistical TDM. Okay, here slots are dynamically allocated to improve bandwidth efficiency. Only when a input line has data to send, the input line gives the slot in the output frame. What this statistical TDM will do means, it will check that the input line have data or not. If it is having means, then it is going to allocate the slot, otherwise it will not allocate the slot for that line or data rate. And here number of slots in each frame is less than number of input line. Multiplexer checks each input line in round robin fashion. Means I told that if the input line having the data means, then there is a forming of slots, otherwise it is not going to set the slot for the input lines. Okay, here you can see that if the line data to send, then multiplexer allocate the slot for the input line. Means if the data is present, means the multiplexer allocate a slots for the input line. If input line having the data means, the multiplexer will allocate the slot, otherwise it will not allocate. Okay, here you can see that otherwise multiplexer skip the line and next line is checked. Suppose you observe that this A is having the data means it will create the slot. Suppose B is not having the data means it is skipped and it will check the third line. It is having the data means it will create the slot. This is the meaning of statistical TDM. Here we are going to explain the concept of addressing of statistical TDM, slot size and no synchronization bit and bandwidth. Okay, here addressing. In synchronization TDM there is no concepts of addressing. In statistical TDM there is a concept of addressing. What is synchronization TDM is not having addressing means output slot need to carry only data of the destination. There is no need for the addressing. Means you can observe here line 1, line B, line C, line D, line E. These are the input lines. These are the frames. Inside the frames there will be a slots. Okay, if there is no data also, it is having the slot for this line C. But here the output slots need to carry both data and address of the destination. Because why it is having both data and the address means you can see that A1 is data, A is address. Why this type means we skipped this slot which is not having the data. So to represent the data belongs to this line means so we have to represent the data also along with the line also. Okay. Next, what is the slot size of statistical TDM? Slot carries both data and the address. I told that in synchronization the slot containing only the data, but in statistical it contains the address and data. So slot carries both data and the address. Here you can see that this black color one is representing the address size. This empty is called as data size. Data size. Adding address size and data size will call it as slot. Okay, and address size should be less than data size. Why we are using this means efficient transmission. Third one is no synchronization bit. In statistical TDM the frame need not to be synchronized then, so synchronization bits are not needed. Okay, next one is bandwidth of statistical TDM. Normally the capacity of a link is less than sum of the capacity of the each channel. Define capacity of the link based on the statistics of the load for each channel. This is means the bandwidth depends on the capacity of the link based on the statistics of the load for each signal. Means it is purely depend on statistics of load for each channel. Okay, this is the end of multiplexing concept. Tomorrow I am going, in next video I am going to explain spreading. Spreading is also types of bandwidth utilization. Okay, thank you.